The shadow found, orbiting the sun. It was never supposed to be there, moving in quiet defiance of expectations, hidden in plain sight within a region of space humanity thought it understood. For years, something circled the sun without revealing its true nature, detectable only through subtle effects that hinted at a presence no model had predicted. To understand why this discovery still unsettles scientists today, we need to revisit how certainty forms in astronomy. The inner solar system is one of the most studied environments in space, mapped repeatedly by telescopes, probes, and simulations refined over decades. Orbits are calculated with extraordinary precision, and deviations are usually explained by known bodies or well-understood forces. Stability in this region is assumed. That assumption began to weaken when observations refused to align. Tiny discrepancies appeared in expected trajectories and measurements, deviations so small they were easy to dismiss at first. Yet as data accumulated, these anomalies persisted, repeating with consistency that suggested influence rather than error. Something unseen was exerting pressure, bending expectations without revealing itself directly. Researchers explored conventional explanations with care. Instrument drift, computational limits, and observational bias were all tested and gradually ruled out. The numbers continued to insist on an unseen factor, one that behaved as though it were locked into a stable relationship with the sun, neither fleeting nor chaotic. What made the situation unsettling was the implication of proximity. This was not a distant mystery unfolding at the edge of the solar system, but something close, woven into the sun's domain, where humanity assumed there were few surprises left. The shadow was not hiding in darkness. It was hiding in certainty. As attention focused on the persistent anomalies, the idea of an unseen companion to the sun moved from speculation toward cautious investigation, because the effects were too consistent to ignore. Models were adjusted, recalculated, and expanded to account for every known influence, yet the residual discrepancies remained, resisting simplification. Astronomers began exploring unconventional possibilities, considering whether faint, difficult-to-detect objects could exist in stable orbits close to the sun, concealed by glare and observational limitations. These regions are notoriously challenging to study, overwhelmed by intense light and heat that obscure all but the brightest phenomena. A shadow in such an environment could remain invisible for years. The search expanded beyond direct observation to indirect inference. Subtle gravitational effects, timing variations, and distortions in expected patterns were treated as clues, pieces of a puzzle that could not be seen directly but might be reconstructed through their influence. This approach demanded patience and precision, because misinterpretation could easily transform noise into illusion. What complicated the investigation was how easily alternative explanations resurfaced. Solar activity, plasma interactions, and magnetic phenomena all produce complex effects that are difficult to isolate. Distinguishing between an unknown object and an incomplete understanding of the sun itself became increasingly challenging, blurring the line between discovery and misattribution. As debate continued, the shadow took on a symbolic weight. It represented the possibility that even in regions studied for centuries, unknown structures could persist, hidden not by distance, but by assumption. The sun, long treated as a well-characterized anchor of the solar system, began to feel less familiar. The deeper the inquiry went, the more it exposed a discomforting truth: that certainty in science often reflects the limits of observation rather than the absence of mystery. The conflict intensified as researchers confronted the implications of confirming a shadow orbiting the sun, because doing so would challenge the assumption that proximity guarantees understanding. If an object or structure could exist undetected in such a heavily observed region, It suggested that familiarity itself might be a blindfold, obscuring phenomena that do not fit expected patterns. Competing interpretations divided the scientific community. Some argued that the anomalies pointed toward a previously unknown class of small dark objects capable of surviving extreme solar conditions, while others maintained that the effects could still be explained through complex interactions within the sun's magnetic and plasma environment. Each position carried consequences, either expanding the inventory of solar system bodies or rewriting aspects of solar physics. What made resolution difficult was the absence of decisive evidence. Direct observation remained elusive, and indirect measurements could be interpreted in multiple ways. Every new dataset seemed to strengthen one theory while weakening another, creating a cycle of progress without closure. The shadow existed as a probability rather than a confirmed presence. The debate exposed a deeper tension within scientific exploration. Discovery often relies on anomalies, yet accepting them requires caution to avoid mistaking gaps in knowledge for new entities. In this case, the anomaly persisted long enough to demand attention, but remained ambiguous enough to resist certainty. As discussions grew more intense, the shadow became less about what it was and more about what it represented. It symbolized the limits of observation even in the most studied environments, and the risk of assuming that knowledge is complete simply because questions have not yet been asked. In confronting that uncertainty, scientists were forced to reconsider a foundational belief that the closer we look, the clearer the universe becomes, when in reality, deeper scrutiny can sometimes reveal how much remains concealed. The climax arrived not with a dramatic confirmation, but with a shift in how the mystery was framed, as scientists accepted that the shadow's true significance lay in what it revealed about observation, rather than what it ultimately proved to be. Whether the anomalies pointed to an unseen object, an unfamiliar solar process, or an interaction not yet fully described, the conclusion was the same, that certainty had been overstated in a region assumed to be fully understood. This realization reshaped the investigation. Instead of searching for a single hidden body, researchers began expanding their models, accounting for layers of complexity previously treated as negligible. The sun was no longer viewed as a simple anchor with minor complications, but as a dynamic system capable of masking subtle influences within its overwhelming presence. The resolution did not eliminate the shadow, but it changed its meaning. It became a reminder that knowledge does not progress in a straight line toward clarity, but through cycles of confidence and correction. What appears complete in one generation can reveal blind spots in the next, especially when familiarity dulls curiosity. For humanity, the lesson extended far beyond solar science. The shadow orbiting the sun symbolized how assumptions can obscure discovery, even when we believe we are looking directly at the truth. Exploration is not limited by distance alone, but by the willingness to question what feels settled. Today, the sun still rises as reliably as ever, and the shadow remains unresolved, not as a failure of science, but as evidence of its honesty. Some mysteries persist not because they are unsolvable, but because they demand patience, humility, and a readiness to revise what we think we know. Subscribe to join the journey.